Okay, in this video I'm going to show you in a step-by-step fashion how to troubleshoot your faulty microwave oven. Now before we start, I'm going to go over a few things that you will need to carry out this troubleshooting procedure. You're going to need a good digital multimeter. You can use analogs one as well, but I prefer a digital. You're also going to need a couple of jumper wires. You can get these at Radio Shack or any other electronic supply store. They're relatively inexpensive. You're also going to need a Phillips and slot screwdriver. You're also going to need a 20 k ohm ceramic resistor like this. It could be a 5 watt, a 10 watt, or even higher. If you cannot find a 20 k ohm resistor at your electronic supply store, then you could always look for a lower value, all the way down to a 1K would work. But make sure it has a sufficient wattage, so try and look for a ceramic one. You can also look in old electronics, old television sets and stereo equipment, and they also look like this. That's a ceramic resistor. So you could look for one of these and you could just pull it out of the old equipment and use that. A lot of microwave ovens use a tamper-proof torx screw on the cabinet to open it, so have a tamper-proof torx bit just like these. There's a hole in the middle. You can also get by with a tamper-proof hex key. You can find this at your local hardware store or Home Depot or Lowe's. Okay, so let me go over a few of the problems. I fixed many of these over the years, probably at least 20 of them. My friends have brought me microwave ovens. I've repaired them for work. So I'll go over a few things that are very common. One issue might be there's no power to the microwave at all, and you did verify that your receptacle has power by plugging in another appliance or a lamp just to make sure there is power. Another problem could be that when you turn on the microwave, the light comes on and the turntable spins, but you do not hear the hum of the transformer for the magnetron. So that could be another issue. You could have another problem. Food isn't getting hot enough. You can also have a problem that when you go to push start on the microwave oven, that the breaker trips. So there's a few different problems. I'm going to go over each one. Now the first thing you're going to want to do is make sure the microwave oven has been unplugged. Then you're going to want to remove the cover on the microwave oven. Generally, a lot of microwave ovens will have a screw here and there, and the same on the other side, as well as on the back where it's bent over, one there. And along the top there's going to be one or two, and the same screw here on the opposite side. Okay, once the screws have been removed from the cover, gently grab the sides and you're going to slide it. You tilt it up and pull outward like that. When you put it back, you're going to slide the front edge in and then tilt it down. Okay, the cover has been removed, and on one side of the microwave closest to the control panel, which is right here, you're going to have all the components right in front of you. Now before we touch anything or do anything in the microwave, the first thing you're going to want to do is discharge this capacitor right here. It's an oval capacitor. It's a 2000 volt capacitor. Now even though there is an internal resistor bleeding off the voltage when power is removed, it's still a very good idea to make sure there is no voltage there, because it could be deadly. Now you're going to take the resistor, clip one onto the screwdriver, make sure it's on there good. The other end is going to go to the ground screw on the chassis or any other bare metal part that you can find. Once that's connected to the screwdriver like so, you're going to reach down to the capacitor right there, and you're going to touch it to each terminal. Just hold it there for about 10 seconds. Once you do that terminal, you're going to reach into the other boot right there, touching the other metal terminal, and hold it to that one. Remove the screwdriver. Now, just to make sure it is fully discharged, take the end of the wire, don't touch the clamp, push it against the terminal, reach into the other boot, hold it there a few seconds, and remove it. Now it's also a very good idea to take an insulated pair of needle nose, and once you've done all this, to go between the two and wiggle that around. If you get a loud spark, you didn't do a good job. So there should be no spark between the terminals. This is now discharged. Now you can safely work inside the unit. Now I'm going to point out all the locations of the components. This is your cooling fan. You have your capacitor right here, right next to the capacitor. You zoom in, right here. This little black cylinder, that's your diode, high voltage diode. We'll be testing that. You have your high voltage transformer right here. This is the magnetron that produces the microwaves. Over here on the left side, you have your the PC board low voltage transformer. You have your circuit board. You have the relay located on the circuit board. On the other side of this piece of metal, there's going to be 2 or 3 switches lined up that look like this. This is what the switches look like for the door. Little button on each end. When you push it in and out, it makes the connection between the 2 blades go on and off, and between these 2 blades go on and off. Now right over here, this is the light that shines through the screen. Now on a lot of microwave ovens, you're going to find that there is a little board here where the power supply comes in, and on that board will be a filter like this and a ceramic fuse. Now the fuse is a 15 amp slow blow fuse. It's ceramic. Now if your microwave is not working at all, you have no power display or anything else, you may just want to swap that fuse out because it may have just gotten worn out over time. So if you change that fuse and you notice there's no problems for a little while, then you're good to go. But generally when that fuse blows, there's a problem. Now on this unit, you can see the fuse is in a holder right here. You would just pop this fuse holder open and check the fuse right in there. Now if the microwave oven is powered up and you have the digital display going and you open the door and the light comes on, but the microwave will not turn on, then you could have a problem with one of your switches, which I pointed out earlier, which is this right here. What these switches do is they tells the circuit board that the door is fully closed. And if the door is not fully closed, the microwave will not power on. Now the way to test the switches is very simple. You're going to use a continuity setting on your digital multimeter or a very low ohm resistance setting. The next step, you're going to look at the switch and you're going to see the wires connecting to the switch. You're going to touch one probe of your connector to one lead and the other to that one. Like so. And then you push the button and that verifies the switch is working. Do it to all the switches you can find. It's usually 2 or 3. Now some of them, when you connect it up like you see here, the alarm will already be on, and when you push the button in, it will go off. That there's 2 different types of switches, normally open and normally closed. Now you're only going to test the blades that have the wires attached to it. If you have a switch like this that has 3 and only 2 wires are on the switch, don't bother checking the one that's not connected to anything. Now, many microwave ovens have the power supply feeding through 1 or 2 thermal cutoff switches like that. What that's designed to do is if this gets too hot inside the microwave oven, this circuit opens up and these need to be replaced. Now the way to test them is the same way as the switch I just showed you. You're going to put the continuity tester across both of the terminals like this. Lay one there, and this should have continuity when you touch it. That's a good one. If you touch it and it doesn't go on, you know you have one that blew. You need to replace that. If the fuse is good, the thermal cutoff is good, and all of your door switches are good, you should have full power to the microwave oven. If you don't, the next step is to make sure all of the blade connectors attached to the switches and the thermal cutoff like this, make sure they're plugged in good, and then you're going to have to suspect that your low voltage transformer on the circuit board, which is right here, that is faulty if this display does not come on. You could refer to my other video, and it shows you in detail how to test this part right here if you feel yours is faulty. The link you can click is right here. Now if you turn on the microwave, the light comes on, the turntable is turning, but you do not hear the hum coming out of the microwave oven, then there's a few things that can cause the problem. Now right on the back of the circuit board is a relay, which looks exactly like this once it's removed. This is what the relay looks like. You have 3 pins that go into the circuit board that are soldered in. You got 2 blades sticking up. This is what the relay looks like when it's removed. And I've seen many times that when the microwave is running with the light on and the turntable's moving and you don't hear the transformer humming, that the contacts inside the relay have arced and they no longer make good contact. So what you're going to do to check to make sure this isn't faulty is you're going to make sure everything is put back together in the microwave that you took apart, if you took anything apart. You're going to put a cup of water in there, and you're going to power the microwave up with the cover off. And then while the microwave is running and you don't hear the hum and nothing's getting hot, gently take your screwdriver and just tap like this. Keep tapping the relay. Don't bang it too hard, just keep tapping it. Now when you're tapping it like this, if you hear the hum come on and the light dim, then you're going to know the magnetron right here is now active because you're getting power feeding into the primary side of the high voltage transformer. And that would indicate you have bad contacts in your relay. You would then have to desolder the relay from the circuit board and install a new one like this. It's a 12-volt relay. Okay, so once you've established that tapping on the relay does not cause the transformer to be powered up to turn on the magnetron, you should hear a hum when it's running. If you don't hear a hum, it's not running right. Then the next step is to disconnect the power and discharge the capacitor once again. Once the capacitor has been discharged, you're going to take your digital multimeter on the high voltage AC setting, connect up one of your alligator clips to one of the probes, reach in with the other end, clamp it onto the blade terminal of the primary side, which is the wires coming from the board. You don't want to touch these wires that are red. Stay away from these. Anything going to the capacitor, those are all high voltage. Take the other probe on the AC high voltage setting, and you're going to take that and connect that to the other side of the transformer. And now you're going to plug the microwave oven back in again and don't touch anything. Next you're going to want to put the cup of water in the microwave and repeat the procedure as before, just like you're going to cook something. And as soon as you push start, you're going to want to look at this right here. Make sure you see 120 volts being fed into the transformer. If you see 120 and you still don't hear the hum, then we can move forward. If you don't see 120, then that's going to indicate that there's definitely an issue with the relay mounted on the circuit board. You want to correct that before anything else. More than likely, once you correct that, everything will work fine. Now if you do see 120 volts at the blade terminals on the primary side of the transformer, which is the real heavy wires wound, then we can move to the next step. So you see 120 volts on these terminals as the microwave is running, but you still do not hear the hum. The next step is to turn off the microwave oven and unplug it and discharge the capacitor once again. Once the capacitor has been discharged and the plug has been removed, you can remove this connector from here, like that. You're going to take a piece of masking tape and you're going to notice that the diode is connected to one blade, which is this wire, and the other blade goes into a different spot on the transformer. Just make sure you tape together the diode with the wire that's on the same blade. Now to release the top connector, you have to push down with a small pointed tool like this in the blade connector and pull, and it will release. Once you release the blade connector, I want you to refer to my other video. It's in the link you see right here. Next to this link you'll see a number. That is the position in the video where you can jump to see just the testing for this transformer. If the transformer passes the test, alright, so the next step now would be to check out the magnetron. There's a Phillips screw holding one side in. Unscrew that. Okay, so you remove the screw holding in the magnetron. There might be a little bit of a clip, so just rotate it a bit and then pull it out. Now once you take out the magnetron, inspect the magnets, these donut magnets right here. Make sure they're not cracked. Check all the way around. Shake it, make sure there's no rattling. Check the end, make sure nothing's cracked. So that looks good. Now the way to test this, go to your low ohm setting on your meter. In this case mine goes down to 200. Connect one probe to one terminal, the other to the other terminal, and you should have a very, very low reading like you see here. You don't want a dead short. You don't want to see 3 zeros, but you want to see anywhere from 0.1 to 0.3 in that range. That's a good one. The next test for the magnetron is to raise your setting to the highest that you have for resistance. I'll put mine to a 20 meg. I have 2000 megs, but I'll put it to 20. And what you want to do is you want to check. Let the meter go up and flat. Alright. You want to check between each pin of the magnetron to the body itself. You should see no reading show up on this meter. Alright? Nothing. If you see something happening, that's not a good sign. Check that one. Okay, we've established that the magnetron is good. Now on to the next step. Okay, the magnetron is all back in since we've verified that's okay. The transformer you verified from my other video, that's okay. Make sure the connector goes back in the same way you took it out. This wire here goes with the diode, so that's going to leave us two things to check out now. We're going to check out the capacitor and the diode. Now usually when a capacitor is bad, when you go to hit power on, you will experience a short circuit blowing the fuse or the circuit breaker. And if your diode is not proper, and if your diode's not working good, you're not going to have good heating of the food, and you also may have a louder noise coming from the magnetron, a different sound, like a different hum. Then you'd want to check that out. So we're going to check out the capacitor first. That's simple to check. Okay, so now you want to remove the clip, the clamp holding down the diode and the capacitor. The diode can only go in one way. It's got a ring connector here and a blade connector here. So reach down. Okay. That's that. And the screw is right here. Nice to have a magnetized screwdriver. You'll see the line on the diode goes to the chassis. Open up this a little bit. Lift up. And pull the capacitor out. Let's back away a little bit. Alright, so there's the capacitor. Okay, so to test the capacitor is very simple. Once you remove it and you know for a fact it's been discharged, just double check by touching the terminals together. Alright. Put your meter on a 20 M setting. One probe in the meter goes to one terminal and the other probe goes to the other terminal. Now when I connect it, you want to see a high reading, like in the millions, like 5 million, and you want to see it slowly go higher and higher and higher, like to 10 million. That would indicate a good capacitor. 4 million, 5 million, 6, 7. As long as it does that, you're good. You don't want a low reading. If you get anything that stays where you connect it or it moves lower, that's a problem. The next test to verify if this is any good, leave one terminal connected and take the other terminal on the 20 meg setting, or 200 if you have it, and connect it to the can. You want to make sure there's no connection between the terminal and the can. Now let's take this one off, move it to here, and you notice no change in the meter. So it's acting properly and there's no connection on that range, so this is good to go. Ruled out the capacitor. Alright, now the way to test the diode, this is the last part to test, is fairly simple if you have a meter that can go very high, like 2000 megohms. And if you don't have that, then what you're going to do is you're going to refer to the link that you see right here. It's going to take you to my microwave oven testing video. And you're also going to see a number in that link, which is going to open in a separate window. You won't lose this window, because that will allow you to jump to the part in the video where this testing is done. Now if you do have a high resistance DMM, then the next step would be to put this on a high setting of say 2000. Let me take my wires. Without using your hands, you're going to take the meter and you're going to put one on the one lead and touch this lead. One direction should go high. Alright, and it should level off around 300 or 350 megohms. That's fine, 275. Now when you flip it around, you should get a low reading, around 40 or so. Okay, that's a good one. So you just confirmed that this one is a good one. This test works all the time as long as you have a high resistance meter. And that's about it. That's all the parts that you can check. Make sure all the wiring harnesses and the connectors are plugged in properly. Make sure there's no loose connections. And you should have no problem figuring out why your microwave is not working properly. If any of these tests failed or you have any loose wires, you should have discovered them by now. And if you have any other questions, please post them in the comments section. I could assist you that way. If you found this video helpful, please rate it a thumbs up, subscribe, and also post links to this video on other websites and blogs. Thank you.